Welcome to David Alexander Maths Tuition. This is chapter 5A on radian measure. Okay, so we're very familiar with degrees. We know there's 360 degrees in a circle, but we're now going to be talking about radians. So what are radians? Now, if I draw in two radiuses, and if these two radiuses have created an arc length which is also the same length as these radiuses, so if this is R and this is R, and also this arc length is also R, so from here to here, if that is also has a length of R, then we have created an angle of 1 radian. There we go. Okay, so that's what 1 radian is. So how many radians are there in 360 degrees? Well, if we go back to our previous picture, and we know that 1 radian means the arc length is R. So if 1 radian is got an arc length of R, how many R's make up the full circumference? So, well, that's quite easy because we know that the circumference of a circle is 2 pi R. So how many R's are there in 2 pi R? Well, I'm just dividing 2 pi R by R. So the answer is 2 pi. So 360 degrees is 2 pi radians. There we go. So this is really important. If you just remember that, even if you don't understand why, I mean, I'm sure it's possible for you to understand why if you just go back and reflect on what I've just said. But 360 degrees is 2 pi radians. So if 360 degrees is 2 pi radians, then 180 degrees is pi radians, 90 degrees is pi over 2 radians, 60 degrees is going from 180 is pi, 60 is pi over 3, 45 is half of pi over 2, so pi over 4, and 30 degrees being half of 60 is pi over 6. So hopefully with a bit of practice you'll start to know these off the top of your head, and then, well, certainly is a lot easier if you're not constantly translating. I do know a lot of students always thinking of trying to translate radians into degrees and back, but after a while with a bit of practice you'll just be working hopefully you'll be working relatively comfortably just in radians. Okay, so in chapter 5A they just want to make sure that you can use your calculator and do some fairly simple calculations, because if we can't do this then some of the trigonometry and the differentiation and integration later on will become a bit of a struggle. So what is the sine of 0.6 radians? The most important thing is make sure that your calculator is in radians and not degrees. And in your year 13 course, you will constantly be irritated by the fact that you're trying to do a calculation in degrees, but your calculator was in radians or vice versa. So you have to make sure you're in the right mode. So I've got this class whiz here. So for me to go from radians to degrees or vice versa is shift menu setup, angle unit, which is number 2, and then I'm selecting either 1 for degree or 2 for radian. So here I'm going to do 2 for radian. So I'm simply typing in sine 0.6, and obviously it's in radian, so that's all I need to do. Sine of 0.6, and what I'm getting there is 0.5646. Cos of 0.3 radians, so cos 0.3, and I'm getting 0.9553. For tan of pi over 4, tan, and then just type in pi over 4, nice and easy, which is 1. And hopefully there'll come a time when you just know automatically that the tan of pi over 4 is 1. Okay, sketch the graph of y equals the sine of x for 0 to 2 pi. So hopefully you can do your sketch of sine of x, which looks like so, and you're probably thinking, okay, so this is 0 degrees, this is 180 degrees, this is 360 degrees, etc, etc. Now hopefully you'll get to a stage where you just know that 360 degrees is 2 pi, and this is what I mean about, you know, you're translating from like one unit to another, but hopefully you'll just know that this is 2 pi, so therefore 180 is pi. So, and hopefully there'll come a time when you can simply do a sketch like this. If I just erase all of this, and you'll just know automatically that 0 to 2 pi is just 1 sine wave. There we go. 2 pi, pi, this maximum here, that is pi over 2, this minimum here is 3 pi over 2, and we are done. And of course, probably should mark in the maximum and the minimums of 1 and negative 1 as well. Okay, so sketch of cos of x. Again, knowing that one full cos wave is 0 to 360, so that's going to be 0 to 2 pi. So, okay, it's not the best sketch here. So this is 2 pi, therefore this is going to be pi. This is pi over 2, and this is 3 pi over 2. So that is the sketch of cos x from 0 to 2 pi, but we want negative pi as well. So again, we can just do a little reflection. Let's extend the axis there. So that is going to go through at negative pi over 2, and it's going to stop there. So this is negative pi, and if you want to mark this in, this is negative pi over 2. So your ability to do quite quickly these sine and cos sketches in radians is really important. So just remember that both for sine and for cos, 0 to 2 pi is the full 0 to 360 if you like. Okay, so here we're doing a sketch of tan x, so hopefully we know how to do normal tan, which goes through like so, and it repeats every 180 degrees. Okay, maybe might already have done more than I need to for this sketch. Okay, so I've slightly, this wave here looks a bit different to all the others for no apparent reason. Okay, so we know that the asymptote here is 90 degrees minus 90. So we just need to be thinking, okay, what is 90 degrees? So we know that 2 pi is 360 degrees. And we know therefore that 180 is pi. So therefore pi over 2 is 90. Okay, so I know these off the top of my head. I'm just putting myself in your shoes and trying to think this is how you're probably going to work it out to begin with. So this first asymptote is pi over 2. This is negative pi over 2. And this one here, remember that tan repeats every 180 degrees. So if it repeats every 180 degrees, that means it repeats every pi radians. So pi plus pi over 2. So this one is 3 pi over 2. And we only wanted a negative pi to pi. Okay, so we need to be thinking about where our x-intercepts are. So we've got 0. The next one will be pi radians later. So here is pi. Therefore, this is going to be negative pi. So these x-intercepts repeat every pi radians. So therefore, if I just want the sketch of negative pi to positive pi, then I'm not interested in this part here. And I'm not interested in this part here or this asymptote either. So there we go. So if we were to delete all that, there is my graph of y equals the tan of x from negative pi through to positive pi.